Welcome back, my friends. Let's talk about the final review. We're going to talk specifically about the law of sines, and we're also going to look at how to find the length of a missing side in a triangle, and then hopefully as well a little something about interest rates. So let's get busy. So we've already looked at some of these. We're going to look at number one first. And it's always important to look at what you have and what they want. So what they want is they say find measure of angle C. So that would be this angle right here. And I would just like to point out that it is opposite to this side right here of 39. And we also have this angle here, and it is opposite this side over here, which is a length of 40. And according to the law of sines, if you have the sine of a particular side and its opposite side, then that is the same thing in a ratio as the other sides with the sine of their opposite angle. So this right here is true, and this right here, and this is all in Google Classic. You have the law of sines written there. And so we're going to look at just angle C. Okay, so we're going to write that, and we're going to put this as sine. So we're going to say sine of angle C, or sine of C, I'll put C degrees, divided by its opposite side, which is 39. This, by the law of sines, has to be the same thing as the sine of any other angle in that triangle divided by its opposite side. So in this case, sine of 72 degrees over 40. And I do recommend that before you evaluate any of those sines, before evaluating that sine, you multiply by 39 to get the other sine by itself. It'll make your calculator work just a little bit nicer. So if you do that, what you get is, try to use just one color, sine of C equals sine of 72 degrees divided by 40 times 39. And now it's time for your calculator. So what you're going to do, I can't really show you, but go ahead and put in sine of 72 degrees into your calculator. And that should give you about 0.95. If you want, I'll give you a little running tally here. So sine of C equals about 0.95. I'll add a 1 here to this digit. Divided by 40 times 39. And again, I'm just going to take that number I got from the calculator, the sine of 72 degrees, and I'm going to divide it by 40. And that's going to give me about 0.023. It doesn't really matter because I'm immediately going to multiply that by 39 and get my new answer, which, let's see which color, use this color, which is about 0.927. Are we done? Because we solved for the thing. No, we are not, because this is just sine of C, right? So this is saying sine of C equals 0.927, but I want to know what C is without the sine. Well, remember that it's a function, a sine function. It's a function like any other function, which means it has input and output. And what this is saying is that the output is 0.927, blah, 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 blah. But what was the input? What was the angle that they plugged in order to get out a sine of 0.927? Well, that's why we need the inverse function. The inverse function, the inverse sine function, will tell us what angle was plugged in to get an output of a certain number. So in other words, if you have a calculator, what you're going to put is you're going to put inverse sine of 0.927. Now most of your calculators, they have a little second button, and then you see right above the sine written in little letters, it says sine to the -1. So that's the inverse sine button. So you just take that of this number, and that will give you the angle. This will give you C, right? And when you punch that in your calculator, it should be about 68 degrees. Hopefully that's what you got. That is your answer, and that's what we're going to put down. So there we go. That's how we use the law of sines to find a missing angle. Let's try one where we have to find a missing side. So I'm going to go to one of those. Oh yes, it's done. Let's go to number 5. And it says find BC. That's one way to name the sides. Other times, the way people name sides is by using the letter of the opposite angle. So since that's an uppercase A, I'm going to call this side A lowercase. And that corresponds to this angle here. And another little piece of advice I'll give is whatever's unknown that you're solving goes in the keyboard. Because remember, if you have, you can also flip the law of sines. So you could say, you could write it like this. Around space there. I hope you understand what I'm talking about. So you can flip it around. That's exactly what I'm going to do. So I'm going to put A over the sine of 30. And this is going to equal whatever other ratio we have given in the triangle. We have a 28 degree and a side of 31. So this is going to give us 31 over sine of 28 degrees. And again, I recommend that you get the A by itself first before evaluating any sine. Although sine of 30 is quite easy. And so now let's write this in simplified form. These would cancel, and so we would get A equals 31 times sine of 30, aka a half, divided by sine of 28. And now we're ready for the calculator. Let's plug in. So that's going to give us 31 times a half, and then we divide all that by the sine of 28, and that's going to give us about 33 degrees. So therefore, we're going to say A is approximately 33 degrees. Notice that we did not need the inverse sign. Okay, the inverse sign is really only if you have an unknown angle. And so because we didn't need to find the angle, we didn't have to use the inverse sign. So we just used the regular signs and punched in our calculator. And I recommend that you practice some of these other ones, and then together we can go over some more on another day. Alrighty. And now we're going to look at this one. And I want you to look at the difference between this problem and one of the previous ones. Do you see the difference? This one here is scalene. It does not have a right angle. Whereas this one is a right triangle. And if it's a right triangle, you don't use the law of sines. You don't use the law of sines. What do you use? Do you remember how to find this? Many of you have forgotten. All you have to do is set up the trig ratio. So in other words, you look at what you know and then you write one based on what you have. So, what I mean is, we have an angle given, and according to that angle, we have an adjacent side, which is this one right here, and we have a hypotenuse, which is this side right here. Well, if we have adjacent and hypotenuse, that sounds like cosine. Right? We have adjacent over hypotenuse. And of course, that equals cosine. So, let's set up the trig ratio. And that's really the key, just setting up the trig ratio. So we're going to say cosine of, should I use parentheses? I did last time. I'll use parentheses. Cosine of 63.1 degrees equals the adjacent, which is 9, divided by the hypotenuse, which is x. And as always, I recommend before you go evaluating cosines is that you isolate the x first. So we're going to multiply both sides by x, and x times x. Cancel that, and we have x cosine of 63.1 degrees equals 9. And now we're going to divide both sides by the cosine of 63.1. Degrees. And what do we get? Well, we get that x equals 9 divided by the cosine of 63. And now it's time for the calculator. 9 divided by cosine of 63.1 equals approximately 19.9, rounded to the nearest 10. And that's it. That's our answer. Again, notice no law of sines, simply a trig ratio, isolating the unknown, evaluating the fraction there, and then you have your answer for that. Again, this is for right triangles. If you have a right triangle and you have to find a missing side, just do this. If it's not a right triangle, then you use the law of sines. And now we will do an interesting. We have here the key to knowing which formula we're working with is really this right here. 3 times per year. That tells me that it's not continuous. So remember, the formula is that the final amount equals the principal times 1 plus, don't forget that 1, R. R is the interest rate as a decimal. And I'll go ahead and fill it in just a second. Divided by N, which is the number of times it's compounded. And this is taken to the power of that same N, in this case it would be 3, times T, where T is the number of years. And now that we have that, we can please notice the color coordination. We can substitute those values in and simply solve using our calculator. So let's do that. We have A equals P, which is 5,345 times 1 plus R. R is, of course, 0.04 because it's 4% as a decimal. Just take 4 and divide it by 100 and get 0.04. The denominator here is 3 because that's how many times per year. And then the exponent is that same 3 times the total number of years, which in this case is 4. And now we can substitute. So let's do that. We have A equals. Don't multiply the principal until the very end. The very last step when you solve will be multiplying the principal. For now, leave it be. And so we have 1 plus, I'd recommend don't do too much at once. So we have 1 plus 0.04 divided by 3. And that's going to give you 0.013 repeated, because it goes 3, 3, 3, 3, 3 forever and ever and ever, to the power of 12. And again, one thing at a time. In fact, I really believe in making fewer calculations and making more steps. It leads to more accurate answers. So in that spirit, I'm only going to do one thing on this next line. All I'm going to do is I'm going to add that 1 to 0.013 because this happened actually a couple times already, that somebody got a little hasty and then they messed up. I'll just say that. And they had a hard time. So if you just add that 1 and then do your power of 12, you'll be okay. So at this point now, we're ready to multiply that. Let's do that in our little calculators. I'm trying to see which color I want. I'm trying not to repeat, but I'm going to have to. Some of these aren't legible. So this is 5,345 times whatever this is to the power of 12, which according to my calculator is 1.17227 ... approximately. And that in turn, if I multiply those, will give me my final answer, which is approximately 6,265 and 79 cents when you round to the nearest cent. And that's that. So let's recap. First of all, you have to figure out which formula you need. It's compound interest 3 times a year, not continuous, not simple interest. And so we have the formula for that, which I wrote there up above, nicely color coordinated. And then just plug stuff in. Just remember, the 4% is 4 divided by 100. That's a decimal of 0.04. So you have to have it as a decimal, and then just don't forget any of those things, and then really just simplify it. And don't do too much at once, and just go carefully step by step, and you won't mess it up. One more problem. So we did one where it was compounded 3 times a year. Let's try one where it's continuous interest. So let's see if we have one like that. So we already worked that one out the other day. Let's go with this one here. And so we have kind of a similar thing, but here we see it's compounded continuously. And that means we're going to use the different formula. So what's that formula, you ask? Well, it's A equals P, the principal, times E, that's right, to the power of RT. But what's RT? R is the interest rate. I have to color code this too. And T is just like last time. It's the number of years. And remember that E is just a number. Let's plug in. So we have A equals the principal 1806, right? That's just the starting amount. Times E to the power of 5%, so that's 0.05. But that's multiplied by 19. But the good news is we're on our way, where we just have to evaluate this. So I'm going to rewrite this and just do one thing. I'm just going to change that exponent so it's a little easier for us, especially with our calculator. So this is going to give you 0.95. And some of your calculators have a button. If you look at LN, some of you think it's IN, but it's actually LN. If you look at that calculator above that, it'll say e to the x. And you can use that in order to do an exponent. Now, some of you already have just the E button, and then you can just take E button to any exponent you want. My calculator here just has an E button, but I know many of the ones that you use don't have a straight E button. You have e to the x. So for you, put e to the x and then put 0.95 and then evaluate. So let's do that right now. I'm going to do it right here for me. And what I get is 2.5857 approximately. So that means that A equals 1806 times approximately 2.5857-ish. And when we multiply that by 1806, we get our final amount, which is, of course, 4,669 and 79 cents. And that is all. I hope that was helpful to you. If you liked it, please give it a like, share it with your friends, subscribe, buy my merch, and have a good day. Thank you, everyone.